All right, class, I'm going to go over that same set of problems pertaining to test scores on a behavioral statistics class, but I wanted to show you all the calculator functions that I used in order to do those values. Remember, if you have a column of data that you're not needing in your problem, go to the top, highlight your L1 column, hit clear, and enter, and that will erase all of them. Type in all your values from your table. Just be very careful as you're doing it. All right, once you have your values entered, second mode, that will take you back out to your calculation screen. All right, from here, hit Stat, right arrow to calculate, one variable statistics, and second one, and it will tell them to compute your descriptive stats on the L1 column. Hit enter. X bar is your mean, so that's where I was getting the 75.58 value. In some of your problems, you will be asked for the sum of the scores and the sum of the scores squared. That's these next two rows. So those don't always go to waste. Those are actually used whenever you're hand calculating, like writing out the formula for standard deviation. I don't require you to go old school with it. You can for sure use technology. I did want to point those two rows out. This SX line is your sample standard deviation, and that's where I was getting the 9.728 figure. If you square that number, that will be your variance. And now consequently, if you're given variance and you need standard deviation, you'll take the square root of that number. So that's how those work together. As far as range, when you arrow down, you take your max value of 93, subtract your min value of 60, and that's where I got a range of 33. I'm not writing any of this out. I'm just going over what I did with the calculator. The written document is on your Google Drive folder. And let me make sure I'm not forgetting anything. Nope, that's it. In the problem below, where the instructor threw a question out and it raised everybody's score by 3 points, in your calculator, you go back to Stat Edit, and if you want to, instead of just mentally adding 3 and putting these numbers in the second column, what you do is you arrow over, go up to the L2 column, and you tell it you want L1 plus 3, and it will pre-populate that column for you. Now, Stat, right arrow, calculate one variable statistics, and you'll want to tell it to do it on column 2, second and 2. And then your same information shows up. Your average, that increased by 3. Standard deviation didn't change. Adding doesn't affect that one. And it also turned out our range was the same. Even though the range, the max and min values increased by 3, they're still 33 units apart. Going back up, the SX line, that's your sample standard deviation, it stayed the same. And then finally, on the last slide, the instructor changed his mind a second time, and instead of making the test worth 100 points, he wanted to double all the scores. and make the test worth 200 points. Stat, edit, highlight your L3 column, 2 times L1, and it will populate your third column with L1 all having doubled. Stat, calculate one variable statistics, but this time you want to do it on L3. Hit enter, and we've got all of our values. Our average doubled from the original. Our standard deviation doubled. Remember, the variance was doubled square, that's 4. We actually multiplied that by 4. The variance changed by a factor of 4. Your range, 186 minus 120 is 66, so the range even doubled. Multiplying your original data by a constant affects a whole lot of things in there in your descriptive statistics. Adding a constant doesn't really change much at all except for the average. I hope this helps.